Welcome, ladies and gentlemen. So what I'd like to do is show you how to graph the cosine function when we have now a vertical translation. So the last part of this series of graphing cosine, you can see I kind of added the k in the blue. So you can see that now when we have a vertical translation, that is going to be now shifting our graph up or down, okay? But just like when we did everything else, you know, first thing we want to do whenever we're graphing is always identify, always go ahead and identify what are going to be the transformations. You know, what are we going to be doing? What is the amplitude? What is the phase shift? What is the period? What is the x scale? So on and so forth. So again, the most important thing I think when graphing is to understand, one, what the parent graph looks like, and then two, identify the important information. So the important information, again, is going to be first and foremost the amplitude, which is the absolute value of a, where a is going to be the value that's multiplied by your function. Well, in this case, you can see we have 1. So absolute value of 1 is just going to be 1. The next thing is to identify the period, right? How long is it going to take for the graph to complete one cycle? So the period, all we're simply going to do is take 2 pi divided by b. Well, b in this case, again, is your value that's multiplied by your variable inside of the function. So b in this case, again, is 1. So therefore, we have 2 pi divided by 1, which equals 2 pi. Then we have our x scale, which our x scale is going to be the distance between each and every critical point. You can see here there's 4 different sections, and there's 5 critical points on the initial period. So when we're doing our scale, just like when you're graphing, you have an x and y scale, we're going to be scaling. We're going to want to use the x scale. To determine the x scale, all we're going to do is take the period divided by 4 here. So I have 2 pi divided by 4, which is pi halves. So we'll have x scale equals 2 pi divided by 4, which equals pi halves. That's good. What am I thinking? Oh, yeah, the phase shift. Phase shift is going to be seeing where you're going to be setting your graph left to right. That is going to be basically if you're moving your graph left to right. And basically the way to do this phase shift I like to do is just to determine what the start is. Well, the start is whenever we have bx minus c, you set that equal to 0. So a lot of times instead of writing phase shift, I'll just kind of do our start. And basically what you're going to do is take bx minus c and set it equal to 0. Basically whatever's inside of your function. Well, in this case, I don't have anything really inside of my function. It's just x. So therefore, x equals 0 is going to be my start. So when I'm starting my graph, I'm going to use this information now to graph. So the last thing we need to do is also now we can now include our vertical translation. And the vertical translation is going to be, are you moving the graph up or down? And this is important actually for your scaling because you know, a lot of people just go by what the amplitude is. Oh, amplitude, you know, up 1, down 1, and that's it. Well, that's all when there's not a vertical translation. Now that we have vertical translation, amplitude is very important. Yes, you are correct. Up 1, down 1, if we were to have a graph that was starting here. But now what you can see here is my graph is actually being shifted 2 units down. So what I like to do whenever I'm graphing these is I like to take my x-axis, right, where the graph would have the intercepts, and I like to move that down based on the transformations. So if I'm moving this graph down 2 units, now my x-axis is being moved 2 units down. So I'm going to draw a nice little dashed line here, okay? And that's going to kind of represent now my new intercept where the graph is going to cross. Now the next thing is, again, you can still see the amplitude is still 1, right? The half distance between the max and the min. The distance between -1 and -3 is 2. Half of that is still 1. So we're still good. So now we just need to set in our scale. We can still use the x-axis for our scale. Our x scale you can see is pi halves, which is actually exactly the same. We actually have exactly the same as our initial scale. However, I am going to do 2 periods here. So rather than just showing 1 period like I did up here, I'm actually going to show 2 full periods. Not because I'm special or anything, but a lot of that's what I ask for my students on their tests. So if you are my student, well, I'm preparing you for your test. So we have pi halves. Then we'll go into pi. Then we have 3 pi over 2. Then we have 2 pi. That would be 4 pi, so this is 5 pi over 2. 6 pi over 2, which is 3 pi. 7 pi over 2. And then 8 pi, or 8 pi over 2, which would be the exact same thing as 4 pi. OK, so now, again, though, remember our start, yes, x is equal to 0, but the graph has been shifted down 2, right? So now we're going to start here. intercept,
can you please come to the main office?
minimum,
Can you please come
intercept,
to the main office?
maximum, right? Because remember, these are representing kind of like our intercept, and this would be our max. So as I go ahead and graph this, just want to make sure you guys can see that it looks exactly the same as our initial period. And then I can just kind of follow the pattern. You go from maximum to your intercept to your minimum to your intercept to the maximum. Boom. Very good. Kind of gets smaller and smaller, but sorry about that. All right, all right, so let's go ahead and get into cosine. So now this cosine, I have y equals -3 cosine of pi x plus 2. So now we got a little added stuff here, right? But the exact same process and everything else is going to be exactly the same. So the first thing we need to do is determine the amplitude. However, I'm going to do this one in red. The amplitude is going to be the absolute value of -3, which we understand is just going to be +3. But remember that negative, though, is going to tell us we are going to have to reflect. And do not forget that, OK? It's very, very important to make sure you do your reflections. Amplitude, our period is now going to be 2 pi divided by pi, which is just equal to 2. Our x scale is going to be 2 divided by 4, which is 1/2. Let's see here, x scale. Our start, or basically our phase shift, is going to be pi x equals 0. Well, divide by pi on both sides. You get x equals 0. So we're going to start at 0 here. And then our vertical translation, you can see, is going to be, oh, this one I didn't write in there, down 2. Well, in this one, we're going to go up 2. So again, just like I did before here, ladies and gentlemen, now in this one, it's going to be a little bit different. I am going to start at wherever our start is at 0. And I'm going to put that in the center. OK? And I'm going to say, OK, I'm going to say that is 0. Now, typically, again, remember we have our amplitude is up 3, -3. But remember, our graph is being shifted up 2. So instead of my y-axis being at 0, or my intercept axis being at 0, it's now going to be at 2. So I'm going to draw a nice little dashed line here. I think that looks all right. That looks straight. This doesn't look as much straight. And then, so that would be -1. 1, 2, 3. OK, and then going up 1. OK, so that'd be 1, 2, 3, 4, 5. OK, now remember, from here, we're going to go up 3 and down 3, right? From your intercept axis, that's where you're going to go up 3 and down 3. All right. So the next thing, though, is determining our scale. So our scale is only going by 1/2. So that means this is going to be 1/2. 1/2 plus 1/2 is just going to be 1. This 1/2 plus 1, it'd be 3/2. And then over here is 2. And then rather than doing 2 periods to the right like I did up here, I'm just going to do a period to the right and a period to the left. So this one would be -1/2. Sometimes I like to do that just because I know that the math is exactly the same. It's just one's positive and one's negative. Now, that's not always the case, especially when you have phase shifts going left and right. But when there's no phase shift, it's a pretty good idea to do it this way. OK. OK, so again, the last thing, remember, I'm going to do the reflection at the very, very end, right? So rather than starting at 1 and doing my graph like I do with the initial period, you can see that this graph is being shifted up 2. Also, notice that the amplitude is 3. That means from that intercept, I need to go up 3. So I'm actually going to do this in black here. So the first point, the starting point, is going to be a distance of 3, right? Because remember, amplitude is the half distance from the max to the min. OK? So the half distance here is going to be distance from the top to that axis, which would be 1, 2, 3. So it's going to be 5. So middle, and then intercept. And then my minimum is going to go down here. Then I go back up to my intercept, and then back up to my max. OK? So the graph would look something like this. All right? However, though, remember, there's a reflection. That means all the points that are above this axis are now going to be below. Anything that's below is now going to be above. And anything that was on the axis is just going to remain the same. Therefore, now, still cross at the same points here. But now you can see that, and then I'll just continue this pattern. So if here's intercept, next one, or if that's minimum, next one would be intercept. Next one would be the max, back down to intercept, back down to minimum. So I'll just continue on. And there you go. So there you go, ladies and gentlemen. That is how you graph the cosine function with a vertical translation. Thanks. Hello.